Okay, we have Mark Rattenbury here. We've invited him along to talk to the soil ESIP group to discuss the geoscience terminology and how that supports. Well, it was such a good intro before. Now you're recording it and I go off. So we've got Mark Rattenbury here. He's a geologist and program leader from GSN Science. He's the chair of the CGI-IUGS Geoscience Terminology Working Group. And he's chatting with us about geoscience terminology, how it supports interoperability. And he's focusing on the CGI vocabularies to support the logical data transfer model of GSI-ML and its sister Earth Science, Earth Resource ML logical data model. And he'll be focusing on how geology data interoperability is sustained and governed in particular. That's a particular interest of this group at the moment, an issue that keeps coming up again. So we thought it'd be great to have Mark along to, it's a different community, geosciences, they've got a different history, different community, different status of standards and vocabularies to support data transfer. So we thought soils community may have a bit to learn from the geosciences. We can have a discussion of parallels, challenges, opportunities, etc. And thank you, Mark, for joining us on your holiday. So thanks.
Thank you, Megan, and thank you, Kathy, for setting this up and the invitation to talk about how we are using terminology in the geosciences space. I think the invitation has come about because I talked to a group last year. The project is the Deep Time Digital Earth Project, and as part of that, we were doing what was called training, which was a series of presentations around various things in the relating to geosciences, and I talked on the geoscience terminology theme for a lot longer than I hope to talk today. Anyway, so that training was at a reasonably basic level, so I pitched it a little bit low. I think the general standard of the group I'm talking to now is probably a little bit more sophisticated, but there may be times when I'm sort of getting a little bit shallow in terms of some of the stuff. So bear with me with some of that. So next slide, please, Kathy. Right, so the talk is broken up into three main sections. I'll talk about some of the the drivers and enablers initially. Then we'll sort of get into the process of the building and delivering controlled vocabularies. And then I'm going to finish up with a section around the governance. So I guess what I bring to this discussion, I'm a geologist. I work for a New Zealand geological research agency. I've been involved in geological mapping for most of my career, geological mapping is a way of conveying geological information, and so therefore it sort of led to why I'm talking in this sort of space now, because ultimately what we're talking about is communication of science information, in my case geoscience information. My soil credentials are pretty slight, but the image you can see on the right is me involved on a soil geochemical baseline study. We were sampling soils over a systematic grid. This one is in the northern part of the South Island, and so I was involved with turning an auger and some of the presentation of the data. Okay, that'll do for me. So next slide. So the drivers and enablers. So basically it comes from three things. It's the need, it's the exemplar, and it's the technology. So the need is where we're trying to exchange information. So I'll speak in terms of geology or geoscience, but this could equally apply to soil or many other science domains. But the need is often driven within countries that have states or provinces that need to federate their information. So an example being Australia, and we've got a couple of Australians, or three or four in the audience today. So very state-based model where they've got agencies which have specific functions around geological surveys, or presumably there's a soil equivalent. But at a federal level, they need to exchange and compare information. And to do that, they need to have standards in place. So that's the need. It's driven by states, provinces needing to federate. And in Europe, you've got the case where you've got a bunch of countries also wanting to federate information. So in this case, under the auspices of the European Union. So these are the sort of the political, the financial heft behind making these standards work. Next slide. For geoscience, we had an exemplar, and this was the One Geology project, which kicked off in the late 2000s. And the aim there was partly a test of the technology. Could we make technology work? But the aim was to get all the participating countries to push up their geological map information to a central portal. It was not a case of replicating information to have it served from a single center. It was about federating the information from a bunch of surveys. So, and those surveys therefore had to provide that information in a standard way. And so the exemplar was this project. It was a major focusing of effort from geological surveys around the world, and ultimately very successful in that we were actually able to create a geological map of the world, but was contributed by all of these surveys individually. Next slide, thank you. Yeah, you don't go to the link. I think that's going to not. And of course, the technology aspect. So, and as I said, to underpin that the One Geology concept, there had to be a whole lot of elements or pieces in the puzzle to enable these standards to be delivered, and this included the logical data models. So in our case, the GSIML, it's a geoscience markup language-based model of how we relate features and concepts and processes. So that's kind of the model you can see in the background of the slide. And then underpinning that is a whole lot of technologies, standards based through the Open Geoscience Consortium and others. So with this element in place, we were actually able to deliver this aim of sharing information. Okay, next slide, thank you. Okay, so terminology is helping geoscientists to describe objects, process, concepts, and the relationships between them. So used well, terminology makes sense to the people who are consuming that information. But if that terminology is confusing, or well, if it's done poorly, then it can confuse that end user, can mislead them, can limit the understanding that can be got. And as it turns out, geoscience has got abundant terminology. A lot of it's in a digital form, a lot of it's accessible in a whole bunch of different formats. A lot of it overlaps, sometimes it's complementary, often it conflicts. So it can be a real mess, and it will continue to be a real mess. But there are ways of making parts of it a lot better. Next slide, thank you. So the ultimate aim is to try and convey unambiguous meaning. So by pushing a term, and this can be in multiple languages, we're trying to define a feature or an object or a process in a way that our end user can understand it. And sometimes those terms may mean something slightly different to somebody, or they may have a similar term, which is exactly the same, sometimes the same, broadly similar, etc. And there's a bunch of natural hierarchies as well. So you can have different types of rocks. For example, I'm going to use rock types as a pretty common one to use. So you can have different categories of rocks. Next slide, thank you. And so these geoscience terminology is built through these controlled vocabularies. So they're lists of terms, they have restrictions on in terms of what can be added. So you can't have too much sort of very closely similar stuff without creating, so we try to control what's in them. So it limits the choice. And ideally it has definitions, so people can actually understand when I say basalt then there'll be a definition associated with it that might say it's got 40 to 55% silica and it's a result of a extrusive volcanic eruption or something like that. So you've got definitions built around what these terms are. But it's also important is where you got that definition from. So what we're trying to do is relate the definition, because actually a lot of different people, different sources can give you different definitions. So this is one way of controlling that process. And in a hierarchical sense, you can have categories, as I said before. So here on the slide, we've got an example of schist. So it's a metamorphic rock, but it's part of a broader group called foliated metamorphic rock. But it also has subcategories within it. In this case, we've got mica schist. The next slide, thanks. You can also have polyhierarchical vocabularies, and this is where you can have a rock, for example, which has got multiple parents. So basalt has got a couple of subcategories listed there, but it's also got a couple of parents potentially. So in this case, we've got basic or mafic igneous rock, and we've also got something which is more texturally based, which is around the grain size. So it's a fine grained igneous rock. So vocabularies can be quite complicated in terms of not only what their children terms are, but they can also have multiple parents. Next slide. So the actual process of building vocabularies has obviously got to involve people who know what they're talking about, so that the subject matter experts. But you also have to understand who you're building that vocabulary for, and therefore, so if it's got an international application or ambitions, then you should be asking people from multiple countries to contribute to that. So what doesn't work is one country imposing something into the international space, because it doesn't get that buy-in internationally. There's also about the scope of these vocabularies. So if it's really big and comprehensive, it's not necessarily more functional. So there are many examples of discrete, smaller vocabularies which are working perfectly well and are probably more useful in an international sense than some of these very granular vocabularies that might be out there. Next slide. So this is the workflow. I think we'll just go straight to the next slide. Thanks, Kathy. And so in the process of building it, it's about creating lists from the working group. In this case, this is one that I was the vocabulary shepherd. So effectively, you can see some of the metadata around the vocabulary process here. So that's got who's kind of looking after the process. It's got some of the edit history down the bottom. It tells you a little bit about where this fits into, in this case, into the Earth Resource ML logical data model, and so on. Next slide. And so this is the beginnings of that list. We often work in the Excel spreadsheet environment, or preferably these days, but for a while we're using the Google Sheets approach, and this is an example of that. But you can see the list of the terms in the second column on the left. You've got your definitions, and right on the right-hand side, you've got some source notes about where that definition came from. And these are starting to be organized hierarchically. So you can see the notation, the H key, you can see that there are different hierarchies involved there. And it refers to the parents as well. Next slide. So here's the process, sort of in a flow diagram point of view. It's about working out the vocabulary requirements, getting some timings on it, getting the team together of people who know stuff, who can go through, and then it's pretty much an iterative process until you get to a point where you feel like it's ready for publication. Next slide, please. And then it's basically a process of publication. So I'm pointing out, or suggesting that the current best practice from our point of view is using an approach that Geological Survey of Queensland have matured quite recently. And so it's about taking that structured Excel spreadsheet and creating a SCOS RDF file from it, and then publishing that through various tools. Next slide, please. And this is kind of the end result. So I'm sticking with this particular vocabulary around the exploration activity type, and so this is an example of the HTML version of that vocabulary once it's published. So you can see things like its definition there, and narrower terms, broader terms potentially, and the links to the resource. Next slide. The SCOS, the RDF XML and the turtle versions of that. We won't need to dwell there, but in there are the list of all of the terms in this particular vocabulary. So next slide. So once you publish, of course, they're not always, well, and should never be regarded as the final word. And I think they're not immune from improvement. So often there's a case of going back and correcting a few minor things, spelling mistakes, for example. But then there may be instances where you want to do something more substantial, and that might be adding or deleting terms, or modifying their definitions or their hierarchies. And this is something that needs to be done in a wider context. So it's not for an individual to do this. It really does require to go back to the governing group. So in my case, through the Geoscience Terminology Working Group, and then we go through another iterative process of looking at those changes and adopting them. Next slide. Synonyms, exact matches, close matches. So what we're trying to do with this is that we've got a list of terms, but we're well aware that in that process of terms, we are not necessarily covering everything in quite the same way that other communities might be using some of those terms. The example I've showed there is actually from a Geoscience Australia vocabulary, or sort of rather the group of geological surveys. And what they have there is an exact match down sort of towards the bottom there, where they're pointing at the same term as within one of the CGI vocabularies. So essentially what we're doing, there's two separate vocabularies working here around different commodities. And for this particular example of dimension stone, they're creating a hard sort of link between the two vocabularies, saying this term and this vocabulary is identical to this term and another. And the reason you might do that is that you may have, you want to have vocabularies which are specific to your particular area, your state or your province or your agency, but you want to be able to demonstrate the links to some of these international vocabularies, for example. Next slide, thank you. Multilingual, so obviously in an international space, there's a lot of languages out there, and it's a little bit, English may be the dominant science language, but it's not to say there's a lot of other valuable pieces of information in many other languages. And I guess that speaks to a lot of that exact match or close match thing, because some of these terms are never going to be exactly the same as their English equivalent. So there may be reasons for sort of suggesting that this particular term is almost the same, but it may have this nuanced difference between this definition versus the English definition. So CGI are trying to do multilingual vocabularies. So you can see the color box looking at this geological age term Eocene. So this is something that Simon has been all over and for a long time. So it's about presenting common use terms in different languages. And in the background there, we're looking at some of the rock name work that we've been doing and trying to get together. So each one of those columns represents a different language, obviously. Next slide. I guess, I'm sort of haven't got a great deal of time, obviously, but in Australia, of course, they've been at the forefront of a lot of this, and this is an example of the what used to be called the AusGen portal. It's now got a new name, but what's happening here is that you've got 3 different agencies serving data to this portal. So it's the Geoscience Australia, which has got the federal country level look view, but you've also got the New South Wales Geological Survey and the Tasmanian Geological Survey serving data to create this. So, and from there you can, I think the next slide, please. You can query one of those sites and it'll give you that information about that particular commodity. I'm looking for copper. So that's talking, and in that vocabulary or that response that you're getting back is a link to the CGI code, which is boxed in red down there. So this is a case of using some of the CGI codes to create a common standard for visualizing information. Next slide, thank you. This is an example from my own patch. We've got a rock and mineral collection and associated database, which we use. It's got a couple of 100,000 samples in it, and from that we often want to extract information based on time or on lithology. So we've actually used the CGI simple lithology vocabulary offline. It's not an online link, but we're using that hierarchy as a way of searching for for different types of rock. So you can imagine that if I'm interested in basalt again as a rock type, using this hierarchical vocabulary, it's going to get me all the fields which have the unit basalt, but it's also going to get me the subunits which may be labeled alkali olivine basalt or tholeiitic basalt. So it's actually helping that search by allowing for that hierarchical bunch of terms. Next slide. So getting on to governance. So as I already talked about, there are a lot of competing vocabularies out there, and they vary a lot in terms of both scope and content. So they can be pretty general, or they can be highly granular. They could be aimed at an international audience, or they may be only applicable in a much smaller context. They can be highly descriptive, or they can be genetic. They can also be objective or quite subjective in places. So, and because of this diversity of terminology and the vocabularies all around the world, the levels of governance vary. So these vocabularies can be managed by international unions and societies, or they may be more localized in terms of a single country or even a state. And then you do have the countries or the state government organizations that may be part of the governance picture. I've just listed some of the main areas in terms of some of the standard geoscience vocabularies there. Next slide. But one of the pretty interesting things to me is, though, that the whole process of vocabularies, which has been going strong for a couple of decades now, is that there's a lot of peaks and troughs in terms of energy and time invested in the process. And I'm trying to capture that sort of schematically in this drawing here, so that you've got from about 2000, you've got this major peak or activities episode when the GSIML model was in development. And then it sort of goes into a period of hiatus, and then there's a bit of a climb when we're looking at a new version or of the model, or and then in parallel, or sometimes not necessarily in parallel but offset, you've got other periods of activity. So in this case, the Inspire project in Europe in grey kicked in, and so on. So you get the sense of ebbs and flows in terms of development. And part of the issue around governance is that when a project's well financed, it's no problem to have that sense of governance. But the real trick is maintaining that governance through periods when there's no investment into the space. Next slide, thanks. So CGI, so we're a commission under the International Union for Geological Sciences. And so we've got a mandate to foster the interoperability exchange of geoscience information. So, and we've been active as a group for 20 years. We've got formalized statutes, but I guess the key thing is that we are aligned to the International Union, which is, it's an international body of some status, if you like, and because of that sort of link, it's giving CGI that level of credibility to work in the standard space. Next slide. Yeah, so I won't go into this in great detail, but we have this mandate to support the logical data models, GSIML and the Earth Resource ML. We've published about 56 vocabularies. But I'd point out that our productivity is kind of in that ebb and flow that I talked about earlier. So right now we're in a little bit of a quiet patch. There's not a huge amount of activity going on, but we have the capability to ramp up in terms of production once there's a major investment or incentive occurring and perhaps coming out of Europe, for example. Okay, next slide. Touch quickly on FAIR principles. I won't go into this in great detail. Findable, accessible, interoperable, and reusable. Next slide. So Simon in the audience is the author, or with his colleagues, on how you can apply these to vocabularies. And so for each vocabulary, there's a bunch of criteria which dictate whether it's findable, the level to which it's accessible, interoperable, and reusable. You can see those terms there. Next slide, please. So this is kind of a self-assessment for where CGI are at in terms of how our vocabularies meet those FAIR principle components. So you can see that we're not perfect. We've definitely got some good things going, but there's certainly some areas for a little bit of improvement. And I won't go too much into that, but I think that's partly, the reason that we were doing reasonably well is that because we've got that comparatively good governance structure around us. Next slide. Okay, so this is kind of the penultimate slide. So we were talking about drivers and enablers for geoscience earlier. So, what's their equivalent in the soil space? So coming back to the need. So it's about being able to exchange information across borders, potentially, or between agencies. And the exemplar, no, I don't know what that could be or is, or so it's something that maybe could be part of a discussion point in the technology. So a lot of the, excuse me, so a lot of the technologies are already in place. And there's been a lot of work in terms of data models in the soil space that I'm only vaguely aware of, but and some of you in the room know a lot more about it than I do. But on the right-hand side, the image is a bunch of lists, which is supposedly supporting the model on the left. Now these are lists of terms. I don't know if they've gone into any sort of equivalent definitions and sources and hierarchical sort of relationship building, but that would be the logical next step to take something like those lists. And depending on the community and the scope and the coverage that you want, you would look at involving the subject matter experts from all of those spaces. Next slide. So this is my concluding slide. It's really talking about soil instead of geoscience, if you like. But if you want it to endure, you need wide collaboration. So yeah, the more involvement from around the world you get, the more likely that terminology will persist into the future. And well, I guess in geoscience we've got a lot of different domains, and I know you do in soil as well. So it's about that spanning all of those domains. And the governance structure. So this, I guess, and this, I think Megan alluded to this earlier. It's about having something that's going to persist through those peaks and troughs of productivity. So it's great when the projects are running and the money's flowing in, but what happens in those gaps? So who's there to keep those vocabularies on the servers and keep the I guess the knowledge around how they operate in a sort of a holding pattern until those resources can be brought to bear again. So I'll conclude there. There's a bunch of links to a whole lot of stuff if anybody needs them. Then let's open this up to discussion.
Awesome, thank you. Kath, might I be able to get you to stop the recording if that's okay?
I guess before I stop, are there clarifying questions?
Okay, are there any clarifying questions? Yeah.
Give it a beat. All right. Hearing none.
Okay.
Thank you, Mark,
Thank
for
you.
a wonderful recording or for a wonderful presentation. This was really interesting, and wrap up.
Thank you.
So hold on a second. Stop the recording.